Okay, so this tutorial is going to go through solid modeling in Rhino so that we can actually generate materials for 3D printing. Right, so I have Rhino opened up here. I'm going to go ahead and zoom in here. I've actually already been working on this file, so I'm going to just go back, and this should just be some basic review for the students here. The first thing we're going to do, we're going to start to draw the tile up. The tile volume for the assignment is 2 inches by 2 inches by 2 inches. But principally, you could take this material and apply it at any scale. The bed of our 3D printer is 8 inches by 8 inches by 6 inches. So bear that in mind if you want to do a larger print. So I'm going to go ahead and I'm just going to draw a box. I'm going to draw this at a scale here. And we'll go through and I'll show you guys how to scale this down. But if we dimension this, you're going to know that this is going to be big. And we'll have to scale it down. I'm going to go ahead and start by drawing this. I'm not going to do anything incredibly fancy here, but I will go ahead and get a symmetrical tile out of this. So I'll go ahead and just mirror that. And we're going to go ahead and create some holes in here. Something that you guys are going to want to pay attention to is our 3D printer has a tolerance, a minimum tolerance for this assignment of 0.04 inches. That's not entirely accurate. You can go a lot tighter than that, but if you're going to be going tighter than that, you're going to be either experimenting with either the printer's capacity to print that thin, or you're going to essentially know what you're doing. And so we'll want to make sure that you're aware of that as you go through it. At a minimum of 0.04 inches, you will in fact be able to do whatever it is you want to do. Okay. Since we're going to be setting this up for 3D printing, before I go and start modeling any surfaces, I want to make sure that I increase the tolerance. So clicking on the cogwheel or typing options will enable us to do that. And if we go under the units here, we can go ahead and first we can set that to inches because we actually are going to be ultimately working in inches. And then we're going to increase this out by a couple of decimal points. And this is important because as we go through and actually want to start to be able to 3D print accurately and model accurately, if we model something beyond our tolerance, you'll run into problems with geometries not joining. You won't be able to split or trim because everything will land in a plus or minus zone of your tolerance. So it's really important. If you guys are having trouble with something that you know should be connecting or should be trimming or splitting, that's going to be something you're going to want to pay attention to. Okay, and it could be that this is the problem. Now, if you are in here and you've modeled this and you realize after the fact that you haven't increased your tolerance and that's the issue, you're going to have to go back and remodel that. Unless, and I'm not sure if Rhino has done this, but at least in versions up to this point, that's been a critical issue. If you have modeled something at a lower tolerance, then it's going to remain at that tolerance. All right, so we'll hit OK. And I'm not going to scale this because I want this to remain at 10 by 10 because I'm going to scale it down. So now we know that we're in inches. And so I'm drawing that in plan, and I'm going to go ahead and then I'm going to make this pretty basic here. We come over here and I'll go ahead and make this that thickness. So we're going to go ahead and now we're going to just generate a series of extrusions. So I'll just extrude this curve. And then I will take this guy and I'm going to go ahead and trim out our actual tile. And I'll join those curves together and I'll extrude that. And I'm going to go ahead and type B for both directions. And you can see what's going on here in the front view here. And now we have this series of guys that are all sort of overlapping and intersecting. We have a good tolerance set, so we can now come in and start to trim and split this away. So I'll take this and split that with this cutting object. And then I'm going to go ahead and select the opposite object, right click, and select the inverse of that. And so now I've come in and I can start to delete away some of the material in here. And you can see now I've got all this working. Alright, and so then we can come in here and very quickly start to model this out. Alright, and at this point I'm going to select the curves, SCL-CRV. I'm just going to go ahead and lock them. I'm going to go ahead and create a copy of this. And I'm going to move that over 20, and we'll create a little matrix here as we start to model this up. The first thing I'm going to do is I'm going to join this. And if I scroll up, you'll note that this is still open. And the reason for that is, if we look in here, we can actually still see the interior edges of this. Our circle punches here have not been modeled solidly. So we're going to want to heal those. And if you guys think that you have something modeled, the first thing I wanted to show you guys is the analysis tool here. Under the analyze toolbar here, we can pull this out. There is a show edges, and so you can turn on and it'll activate all the different edges in your geometry. We can zoom way out. Under here, we can pull this down. You can turn on just the naked edges, and you can see that changed. And then from there, if you click zoom, it'll zoom in on those based on the viewport that you're in and orient you to those things. So we can now see where the holes are in our geometry. Okay, and then from there we can go about trying to heal those things. You can leave that on if you like, but I'm just going to go ahead and do that. Now that I know where the holes are, and then we can type loft, and we can use the surface edges to generate new surfaces with the lofting tool. Select these guys and join them together. Now if I pull up my analyze tool again, you'll note that now the only naked edges that I see are the ones that I haven't healed yet. Okay. Alright, and so we'll go ahead and do that again. So we'll loft from here to here. You'll note that that's still a naked edge because I haven't joined it, so you got to make sure that you have all your stuff joined together. So we'll type join, and if we go under another place we can look for this, just so we can review, we now have a closed poly surface. And so at this point we have successfully designed something that is a 3D printable object. That is to say that this has a distinct inside and a distinct outside that is completely enclosed. All of the geometries are good to go. And so we can test that by typing SEL closed polysurface. You'll see that that's selected and the other surfaces over here are not, even though some of these are in fact polysurfaces. Okay. The other way that you are going to be going about this is, say for example, you have started out with an ellipsoid here and modeled this, and we did a quick twist operation to create something interesting. So this is your tile. You can check this, but this is still a surface. It's a continuous surface, so we can type that by select that by select closed surface, and you can see that there's a series of guys up here. So you'll note that that gets selected, and the poly surface does not, because this has multiple surfaces in it. And it's also under the properties, you can see that it is a closed surface. All right. From this point, what we're going to need to do is we are going to now need to save this, or sorry, mesh this first, because this is not in a condition that is going to be recognized by the 3D printer. The file format for that is STL, or stereolithography. So we'll go ahead and type mesh to turn that into a mesh. And you'll note that this is a little bit of review. At this point we can toggle through the number of polygons. So we can select now our mesh, and I'm going to go ahead and move that away, same distance, so we keep everything at even spacing. And now that we've created this, there's a potential if we haven't increased our tolerance or if something has gone wrong. And the meshing tool sometimes will split and tear this, so we want to make sure that we have a closed mesh still. So now we want to type select closed mesh. Alright, and that's good to go. So that means that we are now ready to export this. So we'll go ahead and export. And you can put this in a file location. And if we scroll through here, find STL, stereolithography. We can go 3D print. Actually, we'll just call this print underscore, and the naming convention, we're going to go first initial, last name, so that way we know who's whose. Then we can go ahead and hit save. Okay. Now, in binary ASCII is all completely okay. And we've actually skipped a really important step in here in our modeling of this. We now know that this is good to go, but if we look at this, we just rediscover that if we go back and dimension this guy, this is, I'll re-enable my snaps here, very large. right? So now we need to actually scale down our tile. I'm going to go ahead and copy that down. Go ahead and create this 20 by 20. Then we'll take this and I'm going to go ahead and scale this. And you can select the width because I have my grid snap on. And I'm just going to type 2 inches. And what that will do is, now that this is occupied in a 2-inch by 2-inch box, 2 by 2. And if we go into the opposite elevation here, we can see, I'll go ahead and just hide that for now, that this is also in our 2-inch by 2-inch boundary. Now this is a very, this will be a lot more material than I probably need to in order to effectively demonstrate what's going on in the tile. So I'm going to go ahead and scale this one-dimensionally so this becomes a little bit thinner. That's going to cut down on the cost of the 3D print. So I'm going to take that. I'm just going to type 0.5, so this will only be ½ inch thick. And I think it will still be able to gauge and get what we want out of this. All right. And this is a relatively basic tile, but this will get us to where we need to be in terms of visualizing or generating our 3D print. Okay. All right. And so that should get you covered, and that is everything you need to know. We'll just go ahead and export this one more time. To replace that file, hit save. Yes, we want to replace it. Binary is fine. I always turn off the export open objects, because the only time you're ever going to be exporting an STL file is, generally speaking anyways, is going to be for 3D printing. So go ahead and OK. And it was successful, implying that this is still a closed object. Alright. So with that said, we are ready to email that to me, or ready to send it to whoever is going to be running the 3D printer and doing their cost analysis.